So today in we are going to start our next chapter, that is gravitation. Fine, gravitation. So in this lecture we are going to study first the concept of gravitation. Fine. After that, Newton's law of gravitation. Fine. Then some of the numericals based on this Newton's law of gravitation. After that, the concept of free fall, then acceleration due to gravity article. Fine. Then weight of an object on moon. Fine. So these are the topics that we are going to study in this chapter. Fine. Let's start with the concept of gravitation. I hope you all have studied that once an apple fell from a tree, then Newton saw that and generalized, fine, the concept of gravitation. Fine. Like, suppose you have an object and you drop that object from certain height. Fine. Clear? You will see that object falls towards the earth. Suppose this is the surface of earth. Fine. That object falls towards the, right. Newton generalized this idea and said that not only earth but every object in the universe attracts every other object. Means object 1, object 2, if they have mass, fine, they will attract each other. Fine. The force by which the masses attract each other, that is known as force of attraction, or you can say gravitational force of attraction. Fine. In this universe, the bodies which has mass, fine, they will attract each other. That force of attraction is known as force of gravitation or gravitational force of attraction or simple gravitational force. Fine. Is that clear? So how can we define gravitation? Now look, how can we define gravitation? Now, gravitation is the force of attraction between any two bodies in the universe. Fine. For example, if we talk about Earth, fine, it attracts or pulls all objects lying near to the surface of Earth. Fine. The force with which the Earth pulls the objects towards its center is known as gravitational force of Earth, or you can say gravity of. Fine. The force with which the Earth pulls the objects towards its center is called gravitational force of Earth, or you can say gravity of Earth. That force is known as gravity, right? So this is all about gravitation only. Fine. Means two masses, they will attract each other. Fine. Remember one thing, gravitational force is always attractive in nature. It is always attractive. It can't be repulsive. Fine. So two objects which has mass, they will attract each other. Fine. That is gravitational force. That force is known as gravitational force. Right. So let's talk about the main concept, that is universal law of gravitation. Universal law of gravitation, given by Sir Isaac Newton, or you can say Newton's law of gravitation, right? This law is also known as Newton's law of gravitation. Now suppose you have two masses, mass m1 and mass m2. Fine. They are separated by distance d. We have two masses m1 and m2. They are separated by distance d. Means d is the distance between object m1 and m2. Suppose a and b are these two objects. Fine. A has mass m1 and b has mass m2. These two masses are separated by distance d. Right. Now, according to gravitational law of gravitation, or gravitation, according to the concept of gravitation, if these two bodies has mass, fine, they will attract each other. Now, the universal law of gravitation will explain, will give the concept of force of gravitation between these two bodies. Fine. According to the law of gravitation, first point is force of attraction between two masses is directly proportional to the product of magnitudes of masses. Fine. So m1 and m2 are the magnitude of their masses. Fine. So the force of attraction between two masses is directly proportional. Is directly proportional to the product of their magnitudes of masses. Means product of m1 and m2. Means greater the mass, greater will be the force of attraction. Right. Second is force of attraction is inversely proportional to the square of distance between masses. Force of attraction means F is inversely proportional. Inversely means 1 upon to the square of distance between them. So distance between them is d square. Square of distance between. I'm repeating again. First point is force of attraction between the bodies is directly proportional to the product of their masses. Means m1 into m2. and inversely proportional to the square of distance between. Distance between them is d, right? Square of distance between them. It is inversely proportional. That's why it is 1 upon d square. Let me call this equation number 1 and equation, right? Now, combining equation 1 and 2, we have f is proportional to m1 m2 upon d square. F is proportional to m1 m2 upon d square, right? So we know that whenever we use equality instead of this proportionality, we have to apply a proportionality constant. Fine. In this case, we have gravitational constant G. Fine. When we apply equality instead of proportionality, we have to apply a proportionality constant. In this case, we have capital G. Clear? So m1 m2 upon d square as it is, right? So f becomes capital G m1 m2 upon d square, where G is called gravitational constant, or you can say universal gravitational constant, right? Gravitational constant or universal gravitational constant. Fine. Now, I'm repeating again. We started from first point, that is F is proportional to m1 m2, means product of their masses, inversely proportional to the square of distance between these two masses, right? When you combine these two equations, it becomes m1 m2 upon d square. Fine. When we use equality instead of proportionality, fine, we have to use a proportionality constant, and that proportionality constant is capital G. Fine. And this G is known as universal gravitational constant, right? Now, as per the relation, we have F is equals to G m1 m2 upon d square. Now, how to define this gravitational constant G? How to define this constant? If m1 is equals to m2 is equal to 1 kg, means we have unit masses, and the distance between these two masses is 1 meter. Now look, when you put these values, we have F is equals to G 1 into 1 upon 1 square. So it becomes F is equals to G. This is how you can define a gravitational constant. Fine. So how to define it? Gravitational constant, gravitational constant is defined as the gravitational force between two objects of unit masses and separated and separated by a unit distance from each other. right? So this gravitational constant is defined as the gravitational force. This is the gravitational force between the two objects, that is m1 and m2, of unit masses, means m1 m2, they both are 1 kg and separated by a unit distance. Unit distance means 1 meter. Fine. So these two masses are separated by distance 1 meter. This is how we can define the gravitational constant. Right? Is that clear, everyone? If you have any doubt, you can tell me. Right. So gravitational constant is the gravitational force when we have both masses of unit mass. We have two objects of unit mass and they are separated by distance 1 or unit distance. Clear, everyone? Right. So let's discuss some of the points. Importance of universal law of gravitation. Fine. Universal law of gravitation. First point is uh, this universal law of gravitation explain several phenomena. Like first of all is force that binds us to earth. First one, right? Force that binds us to the earth, right? Then the motion of moon around earth, right? Next, flow of water, flow of water in rivers is due to the gravitational force of gravitational force, right? Is that clear, everyone? Is that clear, everyone? Good. Now, there is a concept of motion of moon, motion of moon around earth and centripetal force in your NCRT. Do you have your NCRT books with you? Do you have your NCRT books with you? Right. So let's discuss the concept of motion of moon around the sun and centripetal force. Fine. Now we know that the force which is responsible for keeping an object in the circular path is known as centripetal force. That force is known as centripetal force. Let me explain it. Suppose here is your circular path. Fine. The center of the circle. Fine. Suppose you have a thread. You tie a stone with this thread and rotate it like this. Fine. So the force which is responsible to keep this object in this circular path, that force is known as centripetal force, which acts towards the center. Centripetal force always acts towards the center. Remember this, right? Now, the motion of the moon around the earth is due to the centripetal force. Suppose here is your earth and moon. Fine. The force due to which the motion of moon is circular is centripetal force. Fine. And that centripetal force, this centripetal force is provided by the gravitational force on gravitational force of attraction. Gravitational force of attraction of, right? So the motion of moon around the sun, fine, is due to the centripetal force. This centripetal force keeps this moon, fine, in the circular path around the sun. And this centripetal force is provided by the gravitational force of attraction between these two. Fine. This is the concept of actually the motion of moon around the earth and the centripetal force. I hope it is clear to you all. Remember this thing. The centripetal force, fine, is provided by gravitational force of attraction between these two masses. Is that clear, everyone? Right. So great. So we have the relation F is equals to G m1 m2 upon d square, right? Now let's I'll tell you the value of this gravitational constant. Fine. The value of this gravitational constant is 6.67 into 10 raised to power minus 11 into 10 raised to power minus 11 Newton meter square per kg square. Its SI unit is important for 1 mark question for MCQ part. Remember this. Fine. Now look, G is equals to, just cross multiply it. It becomes F d square upon m1 m2, right? For force we have Newton. D is distance. Square of d means meter square upon mass kilogram. Mass kilogram. It becomes kg square. So which becomes Newton meter square per kg square. So the SI unit of gravitational constant is Newton meter square per kg square. Is that clear, everyone? You have to remember the value of this gravitational constant, that is 6.67 into 10 raised to power minus 11 Newton meter square per kg square. Is that clear, everyone? Value of G, that is 6.7 into 10 raised to power minus 11 Newton meters per kg. Great. So in the next lecture, we will solve the numericals based on this topic. Okay, let's solve 1 or 2 numericals based on this topic. Till now, we have only one formula, that is F is equals to G m1 m2 upon d square, right? Where m1 m2 are the masses, G is the gravitational constant, d is the distance between these two masses, F is force of gravitation, right? So the first question is, Question number one is, find the gravitational force, find the gravitational force between Earth and an object of 2 kg mass placed on its surface, full stop, given that mass of Earth is equals to 6 into 10 raised to power 24 kg, and radius of Earth is equals to 6.4 into 10 raised to power 6 meters. Right? So find the gravitational force between the Earth and object. We have two objects. First is Earth and the second one is object. So radius is 6.4 into 10 raised to power 6 meters. That is the distance between the Earth and the object, right? Mass of the Earth is, that is 6 into 10 raised to power 24 kg. Mass of this object is 2 kg. Means M1 is 2 kg. M2 is 6 into 10 raised to power 24 kg, right? After that, capital G, the value of G is 6.67 into 10 raised to power minus 11 Newton meter square per kg square. This value is not given in the question. You have to remember this value, the value of G, constant. Fine. So M1, M2, G, and the value of D is 6.4 into 10 raised to power 6 meters. Now we have the formula, that is F is equals to G M1 M2 upon D square, right? Just put all the values, it becomes 6.67 into 10 raised to power minus 11. M1 is 2, M2 is 6 into 10 raised to power 24 upon D square, means 6.4 into 6.4 into 10 raised to power 6 into 10 raised to power 6, right? Squaring D. So 6.4 into 6.4, similarly 10 raised to power 6 into 10 raised to power 6. Now how to solve this calculation? First of all, it becomes 6.67 into 2 into 6 becomes 12 upon 6.4 into 6.4, right? 10 raised to power. Base same, powers will add, means minus 11 plus 24. Similarly, in the denominator, it becomes 6 plus 6, 12. Base same, powers will add. Now this will be equal to 6.67 into 10 raised into 12 upon 6.4 into 6.4 into 10 raised to power 24 minus 11 is 13. 24 minus 11 is 13. When you shift this 12 to numerator, it becomes minus 12. Fine. So it becomes 6.67 into 12 upon 6.4 into 6.4 into 10 raised to power 1. That is 10 on. Is that clear, everyone? Okay, all of you, please multiply these values. 6.67 into 12, that will be equal to 80.04 into 10 upon 6.4 into 6.4, that will be equal to approximately 40.96, right? So it becomes 800.4 upon 40.96. which is approximately equal to 19.5 Newton, because it is force. So that's the unit of force is Newton. Just look at this question. Have you all done? Reply please. Have you all done? Great. Good. So let's recall all the points that we did today. So starting with gravitation, fine. The various topics that we will study in this chapter, that is gravitation, Newton's law of gravitation, free fall, acceleration due to gravity, weight of an object on, right? Gravitational force is always attractive in nature. Gravitation is actually the force of attraction between any two bodies in this universe, right? So then, universal law of gravitation. Force is directly proportional to the product of their masses and inversely proportional to the square of distance between these two masses. Combining these two equations, we have F is proportional to m1 m2 upon d square. uh, Capital G is the universal gravitational constant. When you apply equality instead of this proportionality, we have to apply a proportionality constant. That proportionality constant is capital G, right? And this G is known as universal gravitational constant, right? So if m1 and m2 both are 1 kg, d is 1 meter, in that case F becomes G. Means gravitational force, gravitational constant is the gravitational force between the two masses, between the two objects of unit masses and unit distance. Fine, they are separated by unit distance, right? Some of the points that explain the importance of universal law of gravitation. First is, it is the force which binds us to the earth. When if you talk about the motion of the moon around the earth, it is due to the gravitation only. Find the flow of water in the rivers is due to the gravitational force, right? After this, when you talk about the value of capital G, right? So the gravitational constant, the value of gravitational constant is 6.67 into 10 raised to power minus 11 Newton meter square per kg square. Fine, SI unit is important for your MCQ questions. So a centripetal force and the motion of moon around the earth. Fine. So when the moon rotates, move around the earth, so centripetal force is required to maintain the circular motion, and that centripetal force is provided by the gravitational force of attraction. Fine, that centripetal force is provided by the gravitational force. Fine. After that, we have this numerical. Fine. Find the gravitational force between the object. First object is 2 kg, second is the earth and object, separated by distance 6.4 into 10 raised to power 6 meters, right? The value of G is 6.67 into 10 raised to power minus. Now put all these values. Fine. Uh, Please don't involve this 10 raised to power this minus 11, 24 in these quantities. solve 10 powers of 10 as separate terms. Fine. It will be easy for you people to solve the calculations. Remember this. Fine. So base same power will add. So minus 11 plus 24. Similarly, 6 plus 6 becomes 12. When we shift this power to numerator, it becomes minus 12. So 24 minus 11 is 13. When you shift this to upper side, it becomes minus 12. So 13 minus 12, it becomes 10. Just multiply and divide it, it becomes 19.5. Is that clear, everyone? Is that right?